So now we're looking at the contractile cells of the cardiac muscle. We're going to observe the voltage-gated opening of an L-type calcium channel sustained by beta-adrenergic stimulation. In this case, we're using norepinephrine as the agonist. It's circulating through the extracellular space, and then it comes in contact with the beta-1 receptor, which activates the G protein, which you see here is the brown complex made up of beta, gamma, and alpha subunits. The alpha subunit activates the adenylyl cyclase, which activates cyclic AMP, seen here as the black triangles change into yellow triangles.
The activation of CAMP will activate protein kinase A, which phosphorylates the voltage-gated L-type calcium channels. The opening of these channels will allow a huge influx of the extracellular calcium channel to the intracellular space. As you can see, the black dots here are the calcium ions. They bind to the ryanodine receptors situated on the surface of the SR compartment, letting out more stored calcium ions into the intracellular space. The combination of this influx of the calcium ions and release from the SR compartment induce a binding of the Ca ions onto the filament cells of the cardiac muscle cells, and as you see here, the cardiac muscle cells contract and shortens.
The unbinding of the calcium from the sarcomeres define the relaxation state of the contraction. These calcium ions have two options. They might either return to the sarcoplasmic reticulum or back out into the extracellular space. To pump the calcium ions back to the sarcoplasmic compartment, the phospholipid enzymes on the sarcoplasmic surface have to be activated. Their activator promotes the activity of calcium ATPase pumps, which triggers a faster return of the calcium back to the sarcoplasmic reticulum. Other calcium ions move to the ECF in exchange for sodium ions, as represented here by the red circles.
Due to these two concurrent pathways, the termination of the contraction is hastened, which increases the contractility while also increasing the rate.